Hello everyone, I hope you are having a wonderful day. My name is Kyle Collins and I will be taking you through the second Physics 2212 lab, Lines of Charge. In this video, I will go through the purpose of the lab, explain essentials, show you the experiment, and analyze computational model using GlowScript. Then I will show you results and explain, answer lab questions, and conclude. In this lab, we are going to produce a computational model of two charged tapes exerting an electrical force on each other and use this model to estimate the amount of charge each tape necessary to float one above the other. So essentials, first we're going to need to know the momentum principle, better known as Newton's second law. The law states that force applied to an object is directly proportional to the rate of change of its momentum, and it occurs in the direction of which it's applied. We know that as force equals mass times acceleration. Next, we will need the electric field equation, which is K times our charge over the magnitude of R times R hat. Then we will need the electric force, which is our electric field times Q. Lastly, we will need to know superposition formula. Basically, E net equals E1 plus E2 plus E3 and so on. In this lab, we are going to need some results from lab 1 to compare to this lab. As you can see from lab 1, we found the charge was 1.4 E negative 9, while our E we got from our lab today is 1.12 E to the negative 8. From this, we can see that they are not the same. That is because the lab we're doing today is going to be more accurate because of the smaller step size needed. We also need to know how to find Q in this experiment. We are going to need our force of gravity to equal the electric force. We also have a few assumptions that are to ignore a resistance, assume each U-tape has the same charge. Charge of each U-tape is evenly distributed across the length. Each U-tape can be separated into segments of equal charge. Total charge of each U-tape is the sum of the charges of these segments. Our initial conditions from lab 1 are on the left. Tape width was 0.02 meters, tape length 0.2 meters. Our Q we got, as stated earlier, was 1.4 e to negative 9 from the charged tape. And on the right, we can see that the second piece of tape is the blue going up. This is the system, and the red sphere is the tape on the desk, which is our surrounding. Here is our code. We first found our constant, put in our lab 1 data, and we used our Q, which we found in lab 1, which would give us our magnitudes to equal our gravitational force. Then I had to find our electric field equation, find the top and bottom tapes up here, and then this basically just showed the superposition of the charges. On the right, we can see that the electric field is yellow, gravitational force is green. They are roughly about the same. If you're wondering, the orange spiky part is the electric field of the tapes. With this, we were able to find our Q value by plugging everything into the equation, the electric field, electric force, and setting that equal to mass times gravity, set those equal to each other and solve for Q. Gives us a more accurate answer because we're using less steps. Every lab has some type of error in it. Could have rounded too much. My code could have had some numbers off, or the tape was messed up from lab 1. However, I am pretty sure everything lab today is correct. Wanted to put out the disclaimer. Questions. What if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated values of the charge you got. Use experimental data to produce a point charge model to the value you got with your line charge model. Our Q in the point charge model was 1.4 e to negative 9, and it was 1.12 e to negative 8 for the line charge, which is a big difference, which was how much more accurate the line charge is. Why do these estimates differ? Which value is more likely to be closer to the real value? Why? Well, the line charge value is closer because they use different levels of precision, but the line charge is better to use in this situation because it utilizes smaller steps, like I said earlier, and we get a more accurate answer. Thank you for watching this lab. I hope you enjoyed it.